Okay, the second video on 3.8, the tangent function. So we're given the graph and we need to find, which is a multiplicative transformation of the graph. Okay, some fancy words. All we need to do is find the period of the function. The period of the function is obviously just one cycle, and we can see that this is one cycle, right? So it starts from negative pi over 4, which is definitely a vertical asymptote, and then we are going all the way to pi over 4. So we are covering pi over 4 units here, pi over 4 units here. So pi over 4 and pi over 4 will make it pi over 2 units. That is the period. In all these cases, you just have to remember a formula, and I can generalize that formula for you, that if I have y is equal to a tan b x plus c plus d, this is a generalized transformed function of tangent, then its period is given by pi over absolute value b. Mind it, it's pi, not 2 pi. In sinusoidal curves, it was 2 pi. Here, it is just pi. So that's about it. Take pi and divide by the coefficient of x, which is 3 in this case, pi over 3. Take pi, divide by the coefficient of theta, which is 1 over 4. So this is 4 pi here. Take pi and divide by the coefficient of pi over 2, which is 2, of course, because 2 jumps up and pi is cancelled. And take pi and divide by the coefficient of x, which is just 1. So the period is just pi in this case. Okay, we have to find what is the vertical asymptote. Okay, I'm gonna go back and tell you the generalized way to find the vertical asymptote. Uh, if this is the generalized transform function, then the VA will be given by all those points where the inside thing of the tan means b times x plus c is n pi over, pi over 2 plus n pi, where n is any integer. So this is the generalized way of finding a vertical asymptote. All you have to do is obviously isolate x from here with a little algebra here, moving things here and there. But yeah, this is how you can find the generalized answer for all the VAs in a tangent function. So that's what we're going to do here. We're going to equate the inside thing of the tan. So x over 2 to pi over 2 plus n pi. Multiplying 2 both the sides, I have x is equal to, and remember this 2 will be multiplied to both the things, right? So 2 is multiplied with pi over 2 to give us pi, and the 2 is multiplied with n pi to give us 2n pi. So this is the final answer. Obviously, you are not seeing n in the options. They have used k as the integer, but it doesn't really matter. I mean, k, n, p, q, whatever you want to use, the point is it should be an integer. And which option is matching? I think it is option B. Yeah, that should be the correct choice. Okay, next time I'm going to take k as the integer. Again, VA, so I'm going to say that 4x is equal to pi over 2 plus k pi. I'm going to divide both sides with 4, so it will look like 1/4 of pi over 2 plus k pi. Obviously, I want to distribute the 1 over 4, so x will be equal to pi over 8 plus k pi over 4, which looks like option A. All right. Here we need to find the VA. So VA is going to be, once again, 2 pi x should be equal to pi over 2 plus k pi. Well, it's funny that pi and pi and pi is gone, dividing pi both the sides. That's another way to think about it. So 2x will be equal to 1 over 2 plus k. I'm going to divide both sides with 2 and, distribute that 2 eventually. So this 1 over 2 came when I divided both sides with 2, and the inside 1 over 2 plus k remains as it is. And finally, the value of x comes out as 1 over 4 plus k over 2. And this is 1 over 4 plus, there you go, option C. We need to find VA once again. So x minus pi, let me just do it over here. So x minus pi should be equal to pi over 2 plus k pi. This is easy to isolate. I'm just going to add pi both the sides, so it will become pi plus pi over 2 plus k pi, and pi plus pi over 2 is 3 pi over 2, 3 pi over 2 plus k pi. I think I'm going to call it a day here. 3 pi over 2 plus k pi, 3 pi over 2. There you go. Option D is the best choice. Okay, here we need to figure out whether, okay, signs of A and B. Not, they're not interested in the values, just the signs. Okay, well, B is definitely easy because B is nothing but the pi over period. Just like pi over absolute value of B was the period. So basically, I just rearrange this. What is the period? I think it's safe to say that it starts from negative 2 pi and goes all the way to 2 pi for one cycle. So the period is 4 pi. So pi over 4 pi is going to be 1 over 4. So B is definitely less than 1. And it's very important that we should understand how the parent function tan of x looks like, because if we know this, then we can very easily find the value, find the sign of a. So the parent function, this is negative pi over 2 and this is pi over 2. So the parent function looks like this. This is the trajectory. And this one also looks like this, right? It's obviously these numbers are different because the period is different, but the trajectory is like this, right? It's not like this. Had it was this, then A will be negative. But no, it's not like this. It is actually similar to its parent function, and that's why we're going to say that A is positive. Okay, here it is different. Now, right at the bat, you can see that the parent would have been like this, but no, this is not like the parent. This is reflected about the x-axis, and if you reflect this about the x-axis, you will get what is given in the question. So A is definitely negative, right? And likewise, the value of B is going to be pi over period. The period will be negative 4 pi to 4 pi, which is 8 pi. So B will be equal to 1 over 8, which is definitely, again, less than 1. So it's option D. Okay, here we need to figure out the values of B and C. That's fine, we can do that. B is easy to figure out. Again, negative pi over 2 to 0. That's one period, which is pi over 2 units, of course. So B will be equal to pi over 2. This 2 jumps up. So it will become 2 pi over pi, which is just 2. So B is 2. So either this or this. Now you can honestly put any number and figure that out, right? So you can probably put pi over 2 and see what is the value of C. So we are going to put pi over 4 comma 0, replacing h with 0. Tan is just tan. B we got as 2. X is pi over 4 and C is unknown. Now, tan of something is 0, and that happens when that something, I mean, the easiest way is, the easiest angle is when that something is also 0. So pi over 4 plus C should be 0, which means that C should be negative pi over 4. And indeed, that is in the options as well. So it should be option C. Right, in this question, we need to find the equation. So I think B is different in the 4 options, at least. Yeah, we can eliminate 2. So the period is negative 2 pi to 2 pi. Obviously, it's 4 pi. So the value of B is pi over 4 pi, which is just 1 over 4. So it cannot be C, it cannot be A. Now, the only difference between B and D is 2 and negative 2. And it has to be negative 2, right? Because the parent would have looked like this, but this is reflected about the x-axis. So definitely this 2 has to be negative in nature. So it should be option D. Okay. Over here, theta is in standard position and the slope of the terminal angle is 1. What is the value of the angle? Basically, that's a fancy way of saying if the slope is nothing but tan of theta, right? So they are saying if tan of theta is 1, then which of the following could be theta? So that's where the unit circle will be really helpful. Uh, it has to be 5 pi over 4. simply because of unit circle. Another way to think about this is 5 pi over 4 is in quadrant 3, right? 5 pi over 4 is here. And in quadrant 3, tan is positive. Tan of pi over 4 and tan of 5 pi over 4 both are 1. So the only option matching is option C. Tan of 3 pi over 4, 3 pi over 4 is here, is negative 1, right? So that's not the correct answer. And pi over 2 and 3 pi over 2 is just out of the way because these are undefined. Okay. Uh, Tan theta is 0. Which of the following could be the measure? That's easy. If the tan of theta is 0, theta can be 0. Theta can be pi, 2 pi, 3 pi, 4 pi, and so on. So I think 2 pi is in the option, so that is the correct choice. Here, they have given that tan of theta is 1 over root 3. So tan of theta, can it be pi over 3? No, because tan of pi over 3 is root 3. So it cannot, it also cannot be 2 pi over 3 because that will also be either plus or minus root 3. So we need 1 over root 3. That's not possible. Right, now for the remaining options C and D, I think I can say C is not the answer because C is 5 pi over 6, which is in quadrant 2, and in quadrant 2 tan is negative, but I need positive angle, right? I mean positive value of tan. So it has to be option D. It is also in quadrant 3, so it has to be positive. And yes, 7 pi over 6 is the reference angle, so it has to be 1 over root 3. And finally, the last question is tan theta is negative root 3. Tan of theta is negative root 3. So which one is theta? It cannot be pi over 3 because that is quadrant 1. Quadrant 1 is positive. It cannot be 5 pi over 6 because this is 1 over root 3 type, minus 1 over root 3. That's not correct. It can be 5 pi over 3 actually, because 5 pi over 3 is in quadrant 4 and its reference is pi over 3. So tan of pi over 3 is obviously just root 3. And since it is in quadrant 4, it has to be negative root 3. So yeah, option C is the correct choice. Okay. They are saying that if the theta is 3 pi over 4, then they are asking the terminal ray has a slope. So basically, that's a fancy way of asking what is tan of 3 pi over 4. And I know that for 3 pi over 4, the reference angle, if we just eliminate 3, is pi over 4. And tan of pi over 4 is 1. But since this is in quadrant 2, in quadrant 2 tan is negative, so I'm going to say it is negative 1, and that is the slope, which is option C. What is the standard position with the measure of this? Once again, sorry, standard position which a measure of theta is 4 pi over 3, and what is the slope? That's the same question, guys, right? So it's tan of 4 pi over 3. Remember that 4 pi over 3 is quadrant 3, so once again it's a positive number. And if we eliminate 4, then tan of pi over 3 is 60 degree, and tan of 60 degree is root of 3. It has to be option D. Okay. Lastly, this is just unit circle. So first I would like to write does not exist because all the odd multiples of pi over 2 does not exist. Okay, sadly there's just one. Then I would like to knock out these things because tan 0 is 0. Tan of minus pi is also 0 because any multiple of pi is just 0. So these are 0. Now let's crack the quadrant 1 first. Tan of pi over 6 is a standard value 1 over root 3, sometimes written as root 3 over 3 as well in a rationalized fashion. Likewise, tan of pi over 4 quadrant 1, so that's positive and obviously that's just 1. This is quadrant 2, it has to be negative, and the reference angle, if we eliminate 5, is pi over 6, which is root 3 over 3. But since it is negative, I will write negative root 3 over 3. Okay, this is in quadrant 3. In quadrant 3, again, tan is positive. So if we eliminate 4, the reference is pi over 3. Tan of pi over 3 is root 3, and that's about it because it is positive. This is in quadrant 4. Quadrant 4 tan is negative, and if I eliminate 7, the answer will be tan of pi over 4, which is 1. but since it is negative, it will be minus 1. Okay, this is interesting because it actually is more than 2 pi, right? Because tan of 13 pi over 6 is nothing but tan of pi plus, sorry, 2 pi plus pi over 6, which basically means that it covered one complete circle and came back to pi over 6. So completing one circle doesn't really change anything because it just comes back to the same position. So this will be tan of pi over 6, and tan of pi over 6 is in quadrant 1, which is a well-known value of 1 over root 3 or root 3 over 3.